Let's take a look at some equations of lines. So here I have 2 points, and I'm going to plot them and find the line in between them. So let's see. -6 for x, 4 for y. So 1, 2, 3, 4. So here's 1 point. And 6 for x, 0 for y. So here's the other point. So I want the line between those. So about right there-ish. Now it looks like I can see the y-intercept, but we're going to have to double check that. So let's see, slope, let's check that out here. So the slope is rise over run, and I can see from this point my rise is a drop from 4 to 0, and then a run to the right from -6 to 6. So looking at the picture, you can check this with a subtraction. We were at 4, we dropped to 0, so that, oops, wrong color, there we go. It's a drop of 4. And then to the right is positive for x, so we went 6 and then another 6, so the run looks like it is 6. And that's my rise. So remember, slope, we use m for that. It's change in y, so that would be 4 minus 0 divided by change in x. So that would be -6 minus 6. And so 4 minus 0 is 4 over -12. In this version over here in the picture, I thought the slope was negative. Oops, 6 and 6 is 12, isn't it? Duh. Okay, 12. So I have -4 over 12. Negative over a positive is negative. Positive over a negative is negative. So these both appear to be the number -1/3. So that's what the slope appears to be. So m, the slope, is -1/3. So one thing we were asked to do here is state the slope as a reduced fraction or integer. Integer is just like a whole number, plus or minus. Just for fun, I'm going to take it a step farther and double check that the y-intercept is really the point 0, 2. So a couple of ways to do that. One way is to consider that we like the equation, or I like the equation, y equals mx plus b. And I believe the m is -1/3, and I have a couple of choices here for x and y, here or here. So I'm going to go with this one right there. So with this point, y is 0. I believe the slope is always -1/3. And here in this point, x is 6. So we should be able to solve this for b. So solving equations, something important. So let's see. I'll view that as 6 over 1. And 3 goes into 6. So this is really -6/3 twice, or -2 times. So now I get -2 plus b is 0. It's a negative connected by addition, so I want to add 2 to each side. -2 plus 2 is 0. 0 plus b is b. 0 plus 2 is 2. So yeah, it looks like the y-intercept is definitely b. So the equation of that line seems to be y equals -1/3 times x plus 2. Nice. If we wanted to double check that, we could plug the other x value in. Let's do it. So the other x value was -6. So y equals -1/3 times -6 plus 2. View that as a fraction. Negative times a negative is a positive. So that's 6/3 plus 2. 3 goes into 6 twice. 2 plus 2 is 4. So our equation says that if x is -6, y is indeed 4, which is that point we started with. Nice work. Let's try another one. All right, let's see. X and y intercepts, those are useful for graphing and other things. So an intercept happens on an axis. So something to consider there, if you are on the x-axis, you have not gone up or down. So on the x-axis, y is equal to 0. Similarly, if you flip that idea, if you are on the y-axis, you have not gone left or right, which means x is stuck at 0. So that would be for the y-intercept, where up here, this would be for an x-intercept. All right, so let's go for the x-intercept by setting y equal to 0. So if y equals 0, then I'm going to get a negative 5x minus 2 times 0 equals negative 20. Well, anything times 0 is 0. So negative 5x equals negative 20. And then here we can break that multiplication by dividing. Negative over a negative is a positive 4. So I think the x-intercept is the point 4, 0. All right, let's find the y-intercept. The y-intercept, let's see, that would be when x is 0. So negative 5 times 0 minus 2y equals negative 20. Negative 5 times 0 is 0. 0 minus 2y is minus 2y. Be careful of your signs. Equals negative 20. Break that multiplication by dividing by negative 2. Number divided by itself is 1. 1 times y is y. Negative over a negative is positive. 2 goes into 20 10 times. So I believe the y-intercept would be 0, 10. How could we check those? Well, we could plug them back in, but that's a lot like doing this here. And that's okay. We could also try graphing this thing right here. So for example, I think if I were to graph this, 1, 2, 3, 4, I have a point there for the x-intercept. And then 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. We got another point up here at 10 for the y-intercept. So the line would go between those 2 points like that. So it has a negative slope, right? What would that slope be? Well, I can see that to get from here to here, I would drop 10 and run 4. So the slope appears to be negative 10 fourths, which is, let's see, that simplifies to negative 5 halves. Y-intercept here would be 10, right? So if we solve this for y, we should see something like that. So I'm just going to do that to double check. I think I've answered the question I want to check. So let's see, new page. Negative 5x minus 2y equals negative 20. We're going to solve for y just to double check. So doing that, let's see, I want to keep this. That's a positive, so I'm going to add 5x to the other side. That's going to leave a negative 2y behind, and I'm going to write it in the order 5x first, then minus 20 second. And those aren't like terms, so I can't do anything more than just put them next to each other. Next, we're going to divide both sides by negative 2. And what that means is that both pieces here are divided by negative 2. Both the 5x is divided by negative 2, and the minus 20 is divided by negative 2. On the other side, negative 2 divided by negative 2 is 1y. And then this can be rewritten as 5 over negative 2 times x, which is the same as negative 5 halves. Whoa, that's a funky 5. And that looks good because that's what the picture showed me when I plotted the intercepts I found. And then negative 20 divided by negative 2 is a plus 10, which is what I believe the y-intercept to be. Yeah, so solving that equation for y, putting it in slope-intercept form matches the intercepts and slope that I found. Good job. Let's try another. All right, so let's see. Find the equation in terms of x of the line through those 2 points. So the first thing I would do is graph them. Even though it doesn't say to, a visual is very helpful. So I'm just going to do a rough sketch. 1, 2, 3, 1. So I definitely have a point right there. And then the other point is -4. So 1, 2, 3, 4, down 5. 1, 2, 3, 4, 5. Graph paper would be nice. So I have a point about here. Yeah, that looks pretty good. All right, so then my line is that sucker right there. So the y-intercept, if my sketch is good, is somewhere between -1 and -2. Could you guess that it's -1.5? Yeah, you could guess that, but I don't know if it's right. So rather than guessing, we're going to calculate. So some things this picture can help with is getting the rise and the run for the slope. So let's see, we're rising from -5 to 1. So that's a rise of 6. And then we're going from -4 over to 3. So that looks like a run of 7. So it looks like the slope is 6 over 7. So let's double check using the slope formula. The slope formula says to take one y value, subtract the other. So change in y would be 1 minus -5. Careful with the signs. And since I started with 1 in the top, I have to start with 3 in the bottom. So that would be 3 minus -4. So that's 1 plus 5, which is 6. Cool. And then this would be 3 plus 4, which is 7. Okay, so the equation and my picture match. So confident about the slope. There's 2 ways to proceed. One way to proceed is to say, hey, I really like this equation, y equals mx plus b. So pick a point like that one and the slope and plug it in to solve for b. So y is 1, slope is 6/7, and x is 3. We can now find b. We'll view that as 3 over 1. And nothing cancels there, so I just get 3 times 6 is 18. 7 times 1 is 7 equals 1. So then I'm going to have to subtract 18/7 to the other side. So let's see. 1, I would have to view that as 7/7 minus 18/7. So I have a common denominator here. So 7 minus 18 would be -11. And so I think that's the y-intercept. Does that look right on my picture? Well, let's see. 7 goes into 11. It's a negative. So -1 and 4/7. 4/7 is close to a half. So that's believable here. I believe that's -1 and 4/7. Looks okay on my picture. Yeah, so I think the equation of this line then is y equals 6/7 times x minus, I would go with the 11/7 as my version. Mixed numbers are good for directions, finding a place, but they're not so good in algebra. To double check, I could plug in the -4 and see if -5 becomes the answer. So I think this is my answer. Just going to do a quick check here. So if I take 6/7 and multiply by -4, and then I subtract 11/7, what do I get? Let's see, 4 times 6 is 24, so that'd be -24/7 minus 11/7. -24 minus 11 is -35, and 7 goes into -35 5 times. So yeah, hey, that looks pretty good. All right, so other way to proceed here was once you found the slope, m equals 6/7, you could use the point slope formula, and that says y minus some y value is equal to the slope times parentheses x minus some x value. And we could use that 0.31 as x1 and y1. So then my equation would be y minus 1 equals 6/7 times x minus 3. And that's an equation right there. You could say, hey, there's my equation. But often systems like you to write y equals and then clean it up. So although that is an okay answer, in some cases you might have to clean it up. So to clean it up, I'd have to distribute the 6/7. 3 times 6 is 18, so that'd be negative 18/7. And then you would have to add this 1 over. So then I would add 1, add 1. That 1 would have to be 7/7, right? So we have a common denominator. Negative 18 plus 7 is negative 11. So we get y equals 6/7 x minus 11/7, which matches what we got before. So you could either use the point-slope form of line to find the whole equation, or you could use the slope-intercept, but either way, you got to find the slope. Plotting those points can help you verify that you have the right slope and the right y-intercept. Highly recommended. But the answer here was just the equation. The graph was a check. Let's try another. All right, here we want to identify the equation based on the graph. So I'm going to identify a few points and use those points. So it looks like I have the point negative 4, 0, possibly the point 0, 3. Looks like it definitely hits there at 6, 4. So if I make a table, it looks like I have the points for x and y, negative 4, 0, 0, 3, and 4, 6. So just to check a couple of things here, notice that when I go from here to here, I'm going up 3, and from here to here, it goes up 3 again. On this side, negative 4 to 0 is up 4, and 0 to 4 is up 4. So the nice thing about these 3 points is they do indeed have the same, oops, I missed, the same rise and run to get from here to here and there to there. So what does that mean? These 3 points definitely line up. So if this point and this point are on the graph, then according to the slopes here, that point right there is on the graph. Well, what is the slope? Well, slope is change in y over change in x, so the slope here appears to be 3/4. And I can see the y-intercept right there. So the equation is y equals 3/4 x plus 3. Check, sure. We could check by plugging in some points, like, for example, this point right here would be one I could plug in, 4, 6. So if I plug in 4, what happens? So I think this is the answer. Double check, y equals 3/4 times 4. So we plug into the equation. Well, let's see. The 4 cancels, right? Because 12 over 4 is 3. And 3 plus 3 is 6, which is what the point identified was earlier. So yeah, I think I got the right line. Nice work. All right, that's it for equations of lines. Hope this was fun and informative. Have a good day and do good math.